Hello everyone. I hope my voice is audible. If you are not able to hear, please write in the chat. We'll start in a few more minutes until more people are joining. Hello everyone. We'll start now. I hope I'm audible and you are also able to see my screen. If you are able to do so, please type in the chat. Thanks again for joining for this week for this course on Python for data science. I'm your teaching assistant for this course for this course. I'm Pratik Chanda. I'm a fourth year PhD student at the Department of Computer Science at IIT Bombay, and I am currently acting as a teaching instructor for this course on at NPTEL. So this is our fourth week and mostly our last week class. Additionally, I am planning to take a 2 hour extra session also, which will be informed to you from the NPTEL coordinator. So we will discuss a few things that was left from last week. So we will first do a quick recap of things we had discussed from last time, and then head back to today's like list of items for today. So, so if you're able to see my screen, feel free to let me know. Uh, okay, so I think since people are still joining, so we can start at this point. If there are any questions that you feel that you have, you can post in the chat. I will try to look at it in the during the course of the session so that we can address them. Additionally, I will try to see if we can take some short quizzes during the course today. So I will share those in the meantime during the course. So we stopped at this particular slide on this if else block settings using pandas data frame. So we last week we had discussed about how to use pandas data frame and get to read tabular structured data sets and analyze them. So this week we will look at the aspects of the control structures using pandas data frame. So we already looked at a few of them from last time. So, but we will finish them the remaining part of it for today's session. So there are a couple of things. For example, in a typical pandas data frame, you would have some kind of columns in the data, which are basically like your features in the data, and some features may be like numerical features or categorical features. So you might have some kind of conditioning filtering kind of mechanism to filter out a subset of the data frame, let's say. So, for example, we were looking at this Toyota data set from last time. And to briefly recap this data set, I think if I just go back to the initial slides, um, so it had this kind of tabular structure, which was this. Let me just show the exact table actually. Yeah, so this was kind of the tabular structure, so which had price, age, kilometer, fuel type, and HP. So all these columns can be looked at as features, and where price is like the target variable, and the remaining ones are the features here. So what we wanted to do is that in case of if we want to filter out a few of the items from the pandas data frame, we can add some kind of conditional uh, Boolean conditions on these columns to filter out this data. For example, if I want all cars with fuel type diesel, I just want to filter that out. So we were looking into those kind of things in this specific setting from last time. So, for example, here, what we are doing is that we are actually calculating the median price based on the target price column, and we are doing dot median to get the median value. And what we are now looking at is that if the median price is greater than equal to some 10,000, I'm printing something. So this is my condition sort of, which I'm adding here. And so if it's true, then you run the intended block, or otherwise you will skip it. Similarly, there is multiple conditions you can define, like under if else conditions. So, for example, you have different such conditions for a particular variable. So, in that case, how do you want to sort of filter things out? So, you typically define by adding multiple um, sorry. Yeah, you can typically add it by having multiple gradations, sort of. So, for example, if your price is less than 8,000, you uh, give it this variable band equal to budget or mid price or premium. So, different conditions you can add here like this within the if else conditions. You can also do this while the filtering mechanism also, like when you are doing calling a pandas data frame within the column itself in the within the index brackets, you can just add this if else conditions in a single line also to get sort of some basic like kind of like a sub query of the data frame. Similarly, you can also do a for loop aspects. Like for example, if here I'm showing a simple example of iterating through all the columns in the data frame, and for each of the columns, I'm getting the average out of it, and I'm printing. So that's, for example, I have columns price, age, and kilometers. So I'm printing the average price, the average age of the in the entire data set, and the average kilometer. So you can loop through the entire columns in the data frame, and you can uh, do mathematical operations on top of it. These are like some simple examples for it. So a loop with if so if you have like two things nested within each other. For example, you also have a if else condition within a for loop. So what you can do is like this, like you loop through the corresponding data frame or the series, pandas series, which we call. And from there, within that, we can also add extra conditions. For example, here, what we are doing is that for fuel type column, we are trying to look at the unique type of the specific fuel type, and we are grouping that by that corresponding fuel type. So fuel type was originally diesel or petrol kind of these gradations. So now you can also group by that, and you are just doing some this grouping by the corresponding fuel type, and based on the number of items in that group, you are adding a if else condition on top of it. So it's a very simplistic example that we are showing here, but you can also think of more complicated examples where you have multiple nested if else conditions within a for loop, or within the if else conditions also you can have multiple for loops also. So multiple things are possible based on your requirement for specific filtering or retrieval settings that you have. So you can actually use, for example, you are trying to do a for loop, and within a for loop you are adding a if else condition, and let's say you already find that your condition is satisfied and you want to not loop through the entirety of the remaining iterations, let's say. So you can use a break character here, which is this specific symbol that you can use to break out of a loop. So for example, here what we are doing is that we are looping through this sorted cards data frame via iter rows. Iter rows basically means that you are iterating through the rows of the data frame. And if I'm seeing my kilometer field is less than equal to 10,000, I would print certain aspects around it, and then I would break it. So that means I won't be going like the first row that I find where kilometer is touching is equal to 10,000 or more. I'm just breaking the condition, and I don't loop through the entire list of rows of the data frame. So this saves a lot of sort of time, computation time also, because if your data frame is too large, then you, of course you don't want to iterate through the entire thing, because if your conditions is already satisfied, then it's not of any use to iterate through all the remaining rows. So that's where you can use break as one of the examples here. Um, so even so there is also another looping mechanism called while loop, which is very similar to for loop, but you also have some extra variables in while loops. So for example, here what we are doing is that we are initiating a variable count, which means that how many of the cars with price is greater than equal to 30,000, and we are summing them up, like the number of cars that are have price greater than equal to 30,000. And then what we are doing here is that we are initiating count equal to 0, and we are setting a threshold. We are trying to see while this condition actually holds actually. So if count equal to 0 and threshold is greater than equal to 10,000, I keep on doing this operations inside, which is threshold minus equal 2000 and count, calculating the count for that threshold. So here what we are simply doing is that we are setting the threshold initially to 30,000, then decreasing by 2,000 at every step. So it becomes 28,000, 26,000, and so on. And for each of this step, we are trying to find the count of the cards that are exceeding this threshold. And so this is where we are kind of looping up. Once we hit the threshold where hit the step where threshold is falling less than equal to 10,000, we break out of that loop. So you don't need a specific break symbol in this case because you already are satisfying from this while condition. So in typical while loops, you actually add a condition when to break out of that. Otherwise, you loop through the entire thing. So in for loop, you also can add specific conditions like this within the for loop argument. But if it's a vanilla for loop where you just do simple looping through the entire iterations, you can add a break symbol to break out of it when you satisfy some condition. So the summary of it is this, that you specify an initial state, which is your, let's say, your threshold here and count here, and you give a Boolean condition to it, and you also update that moves towards the stopping criterion or the point at which your while loop you break out of that while loop. And so these are all like specific characteristics of using while loop. Um, Also, the last one is mostly about functions. So in function, a function basically means that you give a input, and it does some specific operations on that input and gives you an output back. So for example, we are defining a function by this um, by this characteristics, which we call as DEF. DEF stands for define. So DEF, mean price by fuel, is the function name. Within that, we are adding the parameters of the function, like the DEF is the data frame and fuel is the variable that we are having. So what it is doing is that we are looking at the data frame for which fuel type is equal to fuel, which we call it as the subset data frame. So it gives me back the data frame for which my fuel type is equal to fuel, and the output of the function is that I want to calculate the mean of the average price of that subset itself, of that subset data frame itself. So if I now, so I've defined the function here. So now if I want to use the function, so what I can do is that I can call the function like this, mean price by fuel. I can specify the input parameters. DF was equal to Toyota. Toyota is the data frame that we're using, and fuel is diesel as a as a parameter for fuel. And we are putting the subset price dot mean in diesel mean. So what it basically does is that in the Toyota data frame dataset, it's looking for the all the cars with fuel type equal to diesel, and for those cars, it's trying to find the average price. So this is what function is typically. So it operates on input value, and you can specify multiple, like as many inputs as you want, and different types of inputs as you want. And you have to use all the inputs within the function block, and you can process your any operations on top of it, and it returns back you the output of the same. So this is a typical example of a function that we are having. So you can also define a function where you don't have a specific output also. Like many functions actually have settings where you are just processing something, or maybe let's say you have some print statements within the function. So you don't typically have a return statement in those cases. So it's possible that not all functions have a return output. So this is a typical example, like how you can use data frames, pandas data frames in a function using a function and all. Uh, so typical, like there's just a custom function that we defined here, but there are all the things that we were discussing till now. Let's say this dot mean thing that we are using, like which is a pandas data frame utility function. So there is also a function defined. So this dot mean parenthesis is also a function defined within the library itself of pandas that calculates the corresponding data frames, like whatever parameters you are setting, that's average. So those are like kind of typical examples that we have. So now we'll move ahead with the next set of items. You also have something like default, which is let's say so I'm for example here we are trying to define a function filter cars where we are passing in the data frame here. We are also setting some parameters here. So the default parameters is basically when you are, for example, when you are calling this function, let's say filter cars, when you are referencing this function, you may not want to pass actually the parameters. Let's say you just want to pass Toyota. So by default, the value should be taken as 60, 80,000 and fuel equal to none, because those are like the default parameters that are set to the function. So if you can also like you can do away with the calling of the function without setting any parameters to that function, like when you are making a call. But if you're, let's say, if you're making a function called filter cars with your max edge equal to 36 and fuel equal to petrol, then your max edge in the function itself is getting replaced by 36 and fuel is getting replaced by petrol. If you look closely here, like we are not passing max kilometer as a parameter in the function. So since we are not passing that, so the default value is set to 80,000. If you pass max kilometer with a different value, it would get overridden in the function. So this is a specific example where you can use default parameters in a function. So you can have like you can have any descriptive parameter names here, and you can specify default values so that in case of a function call when you are not specifying those parameters, it can still run the code without any errors. Like it can still get the default parameter values and it can give you the output corresponding. So I hope those things were clear. So if there are any specific questions till now, like we can take up and then we can move ahead for the other parts. So if you have any questions, you can feel free to share in the chat. Okay, I think we can then move ahead. There are no questions. So the other thing is about vectorization aspects. I think with NumPy in the previous few classes we had looked at NumPy vectorization and all. So within Pandas also, I think the data frame library also you can use vectorized code. So this is a typical example that we are showing on both sides. One is a very slower uh, implementation of the same logic. And on the right hand side, we are using a vectorized expression, which is much more faster than the left hand slower logic block. So on the left hand side, what we are doing is that we are iterating through the price column in the data frame. And if my price is greater than equal to 15,000, I am appending a sort of a tag to the uh, uh, corresponding car. So I'm adding this labels which is an empty list, starting as an empty list. If my price is greater than equal to 15,000, I'm tagging that card as a premium card, otherwise a standard card. So what I'm doing here is that for each row in that data frame, so I'm iterating through all the rows in the data frame via the only just looking at the column price. And if my price is greater than equal to 15,000 for that card, I'm labeling as premium, otherwise standard. Now, what we are doing here is that once we have this labels list of labels, we are creating a new column actually in the data frame called Toyota band, and there we are assigning it as labels. So what it essentially does is that the data frame initially was having some columns associated with it, like price, age, kilometer, and all. At the end of it, I'm adding a new column to it called band, and for each of the rows, I'm adding the labels as corresponding values for it. So there is a very simple operation, but it's slow because you have to iterate through the entire uh, data frame. If it's like, let's say, 1 lakh entries in the data frame or 2 lakh entries in the data frame, it's very time consuming to iterate through the entire thing. So a easy way to do that is via vectorized expression on the right hand side, which we are showing. So we are starting with Toyota band as a column instantiation of the new column that we are creating, and we are assigning it to this following NumPy vectorized form, which is np.where my Toyota price is greater than equal to 15,000. If it's greater than equal to 15,000, then I'm adding the label as premium, otherwise standard. So this is a NumPy vectorized, like a if else condition kind of in a vectorized format. So so the dot where function basically looks at all the rows, but in a much more faster way, and it is actually just filters for wherever in the column it's greater than equal to 15,000, and the first after the first comma is the if the condition is satisfied, it goes into this second field. Otherwise, it goes into the third field. So there is like the if else condition. So if this condition is satisfied, I go to the first argument. Otherwise, I go to the second argument. So if my Toyota price is greater than equal to 15,000, I add a label of premium. Otherwise, standard. So there's a typical manner in which you can use vectorized formats in pandas. So you can use apply when the logic is genuinely like kind of low wise logic, and no direct vectorized operation actually fits. So in all these scenarios, you can use this vectorized expression. So so this is like one aspect of it, and you can also think of multiple other cases where you might have nested for loops also, where there is a for loop within a for loop and you have to do multiple condition filtering and all. In those cases also you can do vectorized expression because those are much more faster. So if you have a larger data frame, like a large size of the data frame, typically this nested for loop would take a lot of time, so you can use this vectorized expression to get things much more faster. So there is a simple function that I'm showing here. I want you to try out this thing at your end. I think since we have some time, we can take 10 minutes here to just try out this thing. And if you are facing any issues here, because it just summarizes most of the things we have learned here in terms of the plotting and all from last week. So if you have your code base up, like you can also use Google Colab. Just you can type Google Colab and just paste this code there and just try to work it through. Just to understand like how this things look. So I will paste this thing in the chat also because it's a big blog, big code blog. So if you want to try out at your end based on the data, this data set, you can uh, take some time to just analyze different aspects of it. Yeah. So I think, and then I think we will move to the next part, which is on some of the overall concepts around debugging this pandas data frame and all, and some a shorter quiz version of it. So take out some time, like I think 10 minutes. I think we'll start around 3:40 once more once you have done these things. And if you are facing any issues, feel free to type in the chat. I will try to look through them in the meantime. Okay, I think I hope you are able to set it up and see the aspects of the code. We'll move ahead with it because I think it's just a few operations, I think, from the examples we saw last time that we are trying to work out here. So I think the last kind of aspects of it around this pandas data frame is like a few mistakes that people uh, even like kind of make around this when they're trying out for the first time. So, for example, you are actually when trying to read the CSV file, for example, you let's say you have a very big large column, and you like in the final data frame, you are actually seeing a very large column and all. So it might be the case that you actually use the wrong separator for it. So we saw like different aspects where the separator maybe a comma or a semicolon based on how the data are separated in the CSV file or the text file. So you have to use a separator correctly for that. Then I think the other very common mistake is let's say when you're trying to sort of get the column for price from the data frame, might get an error like key error price or let's say key error age or something. So there is also a likely cause that it might be case specific, or you might have space is or wrong. You're calling the wrong name from the column, and also you can use like you have to use check the column names whatever you are specifying in the data frame. Otherwise, you can also do dot columns to get the list of columns, and from there you can index it and get the corresponding uh, sub the panda cities out of it. There is other things about ambiguous truth value errors. So if you are using some conditions on this pandas data series, then those kind of errors might come in. So you would have to use uh, different and this kind of Boolean operators like this, like ampersand and this dash line within parentheses and all, just to make sure that you don't get this kind of errors. Other things like plotting also, like when you have you're trying to connect certain points in the plot, you might have some unsorted x-axis, let's say. So in those cases, how do you uh, do it better so you can do aggregation of it and then sort it afterwards? So multiple such things are there. So these are like a few examples out of it, but I think once you try it out at your end mode, I think those things should be evident. So I think I will give a short 4 minutes quiz here. I think I would like you to probably uh, answer these 6 questions in the chat. Like just serially write your answers 1, 2, 3, 4, 5, 6. Or if you are not able to answer all of them, just write a few of the questions answers, but keep it in a single chat box, not in multiple entries in the chat, so that we know what everyone is able to understand till this point. And then I think we'll move ahead with the remaining sections. So feel free to type in your answers in the chat for the following 6 questions. Okay, I think we were able to sort of few of them. So I think these are very typical questions, I think, from based on what we have already seen from the previous slides. So I think if you watch the recording once more, I think you'll be able to answer them. Or even like if you're writing code side by side or experimenting on this data frames library, I think you'll be able to answer these questions. So moving ahead of this thing, so these are the answers I think which I want to share. So if you are able to answer them mostly correctly, I think that's good. I think otherwise you can also go through the library tutorials once more or go through this recording once more to understand it. So this is a short sort of function question sort of. And the thing is this as follows, that you have to write a function shortlist report that takes your the data frame as input, max budget, max age, and max kilometer as also parameters. And you have to filter cars that satisfy all three constraints. Let's say uh, you have to use the if-else conditions to describe the shortlist size loops through field type values and prints each of the counts. And finally returns the five lowest kilometer candidates and creates a price versus kilometer scatter plot for the shortlist. So basically, you have to filter. Um, First of all, you have to filter from the data frame that satisfies the constraints that you have max budget and max age and max kilometer. And based on that, you can use a if-else condition to describe this shortlist size also. And after that, you will loop through the corresponding field type values and all. So there's a short code block I think you should try out now, just to understand how to write these functions, and which is a basically mix of all the if-else conditions that we discussed till now, as well as the looping strategies with whether you have to use a break condition or not, all those things. So again, take some time out to work this through. If you are facing any doubts or any specific questions here, you can ask in the chat. I will try to answer them once uh, we once we finish this. So you can take out your you can use your Google Colab or any other VS Code library. Using the same data set, you can try these things out. So you can specify your own specific max budget, max edge, max kilometer values. It's your any value that you want to have. Based on that, you can try these things out just to uh, get a clear understanding of the entire operations around it. So yeah, so if you are able to do it, you can let paste in the chat, or if you are facing any doubts, you can also paste in the chat. Okay, I think you are, if you are able to write this code, I think it would be, uh, if you have any doubts at this, for this code, I think you can let me know. Uh, just, sure. Yeah, I think this, from the previous question. For this question, if you need some more time, we can take some time. Otherwise, we can move ahead. So there is a just a simple um, kind of like an aggregation of all the concepts that we were discussing few minutes back as well as from last week. So so you can so there's like a very high level summary of what you can do for this specific setting. So you can read the CSV and verify the shape columns and the data types and the sample rows. Then you can filter on all those things by different aspects of it. So we looked at different operations like select, filtering, sort, create, and renaming of columns and all. We also looked at summarizing categories with value counts grouped by pivot table. So these are some aspects were covered last week also. So if you are there last week, it might be easier for you to recap. Otherwise, you can also go through the YouTube lectures from last week to get an idea of the discussion. So we also looked at how to check for missing values, and if you want to check for duplicate values in the data frame, how to fix those things. Finally, like preparing for different data types, categories, um, and if you want to modify any features, like make it more scaled features, let's say, all those things were discussed last time. So the final aspects are the plots that we had discussed, like in terms of uh, um, so the plots like different scatter plots, line plots, and all. And lastly, the conditions like if else, break conditions, while loop, and different aspects of functions in this pandas data frames. So this is the complete workflow. Of course you have to so this again let's a summary of the entire aspects of it. So what you're doing here is that you're first reading the data frame, the data set from the CSV file, storing in a data frame. Then you are inspecting the data itself, and then you are preparing your data for processing, like preparing in the sense like you are doing multiple operations. Like if you want to create a new feature or a new column, or do you want to normalize, like if you do want to do scaling of certain features or normalization on those features. Then lastly, you would have to do the visualization aspects, like do some plottings on different styles of plots, like line plots, scatter plot that we had discussed, histogram plots and all. And finally, the automation, which is requires like based on the patterns that you are learning from the data, like whatever decisions you want to take. So if you want to filter out certain aspects of the data based on whatever patterns you learned in the data. All these things is the entire life cycle of the data frame, which helps you to understand these aspects. So data frame is actually useful when every operations answers a very clear question. So this is the overall pipeline that we have. So yeah, I think we will move now to the last part for today, which is this on a case study of this on regression and classification. So I think the last course that we had, I think if you are able to see my screen, yeah, I think things on classification and it's on uh, regression aspects. So we'll start on that. So if there are any questions, I can take in few questions during in the meantime, and we can start from there after that. So there is one question. Can we share the code file again? Yeah, you can share your paste your code if you want to on the chat. Yeah, so I think we'll start in 2-3 minutes more. If you have any questions, now is the time to ask for data to data frame and all. And then we'll start with the final aspects of regression and classification and examples around it. So I think yeah, I think we can start now with the next setting. So we'll look at two machine learning case studies today. One is on complete regression workflow, and another is on classification workflow. So we'll look at starting from the raw data itself, like the whatever the features in the data sets and all that, and how do you train your model on top of it and get the final evaluation. So there are two case studies. One is regression. Regression basically says that the output value in a regression setting is a real value, and in classification the output is binary or a class outcome. So it's a category outcome or a binary outcome. So example is like in regression you want to predict the price of pre-owned cars, let's say. So the price field is sort of real value. So it's a regression problem. But if you want to classify personal income, let's say you want to ask whether the personal income is below some threshold or not, then you want to classify it as like medium or high income or low income, those kind of things. So those are called classification because you are categorizing the entire data set into classes like high income, low income, and medium income. So we'll look at the aspects of this regression versus classification aspects. Then we'll look at the regression case study. Then we'll ask for any questions in some sense from regression and then the classification aspects. So the problem statement looks like this: like you have a car marketplace that lists thousands of used vehicles every week, and you have to the sellers often misprice their cars as too high, and the listing never sells them. And too low, if the list is too low, and the seller loses money. So we need a model that predicts a fair market price from the car's attributes. And so why regression we should consider, because price is a continuous numeric variable, so it's not a category. So that's why we consider a regression problem when you predict a number rather than a class. So the target variable is price, and the corresponding features or the key predictors are the aspects here are shown as vehicle age, engine power, kilometers driven, and all those. Um, yeah, so the data set overview is as follows: that you have some numeric and categorical features. Price is your target, and so it's a numeric value, and years of registration is also a numeric value, and so on. Vehicle type, model, brand, and all are all categorical values like model name, manufacturer name, and all. So all these things is a mix of both, and there are at least around like approximately around like 3,70,000 raw listings are there before the cleaning, and there might be some outliers or missing values present in the data also. So all those things are there, and you have to clean the data before processing for the machine learning model. So the regression workflow looks like this: that you first load your data in a pandas data frame. So you typically read from a CSV file. You then clean your data using duplicate. You drop the duplicates, or you fix ranges in the specific features, or you do some imputation aspects. Then you encode the variables or the features. So since there are some categorical features that I was mentioning, like kilometer and all those things, so you have to encode them to make it in an embedding space. So you encode these categorical values. Finally, you do a train test split, because you want to train your model on the train split, and then you want to evaluate your model on the test split. So that's your train test split, and finally you want to train a regression model, and finally evaluate the score. So we'll use a linear regression here as well as a random forest model, and we'll so every step below is shown as a runnable Python. So you can copy to your notebook also, and you can follow along these examples. So so you're gonna, I think, so I'm sharing the, I think, what I will do is I will just share the link to the slide so that you can all copy the code as we go along. So I'm just copying the slides in the chat. Um, so if you're able to access it, you can just copy the code. If you have your Google Colab or Jupyter Notebook, VS Code, whatever, like whatever platform you want to use, you can just use it there. So we are first importing, we're first trying to write the regression code here. We want to have first importing of all the libraries here. So we import the pandas data frame and Seaborn for the plotting, matplotlib, and all those things. And we also use this specific library called sklearn, which is called scikit-learn, which has multiple such models for linear regression. So you don't have to actually implement the algorithm as such. You can just use a function call from those libraries. But you are also encouraged to look at the algorithm itself. Since it's not an algorithm course as such in this thing, so we won't actually would be looking into the specific algorithms or the machine learning aspects of it. So we'll just directly jump to the Python code related setups for it. So we'll start with this. Like we'll load the pd.read CSV library. I think the dataset is already shared probably with the in the course materials with you, so you can just check from there. Or so just maybe just put out a confirmation if that's the case. Otherwise, you can just follow uh, the aspects from here. So so yeah, so I think now what we are trying to do is that we loaded the dataset as follows, and we are storing it as a pandas data frame from the CSV file. We are inspecting first, like the cars.shape, cars.info, cars.describe, and all. And then finally, we in this step two, we are trying to clean the data, like in terms of pre-process the data. So we want to drop any duplicates or let's say any missing values if there are there. So how do we tackle that and all those things? So you can drop, let's say, some kind of identifier on high cardinality columns, like let's say date crawled, date created, and all those things. So this kind of columns are not much required in your training your model because those are less important features. So you might drop them. So those are like one of the few examples. So you also have to drop duplicates from the dataset. So you use drop duplicates to do that, and you also want to keep within a particular range. So any car with year of registration greater than equal to 1950, you want to only keep it, and less than equal to 2018, you want to keep it. So it's a old data set, so that's why it's still 2018. But you can, based on your recent data sets or whatever data sets you're working on, you can change these things to actually look at a subset of the data that you want to train your model on. So instead of training on your entire model. You want to only train on a subset of them. So all these things are possible. Um, so here we are looking at year of registration within 1950 to 2018. And if my car price is between 115, 1,50,000, and car power is between 10 and 500, I only want to train my model on that. Finally, once I have those things, I can also uh, substitute for the missing values, like any uh, like uh, NaN values, let's say. You are filling with corresponding the mode of the thing. So mode is basically the highest frequency. So whatever is the highest frequency, you are just replacing the missing values with that. So for example, in fuel type, gearbox, and vehicle type, in the entire data set, based on uh, after the filtering and all the duplicate removal and all, whatever is the highest frequency for fuel type, gearbox, and vehicle type, we are replacing the missing values with those. So it's a very like a simple uh, a kind of a simple alternative to mitigate these missing values, where you can just replace it with the highest occurring kind of values, because in all probability, your missing values might actually, in the original format, might actually contain those high frequency values. So it's a very standard setting that you can use. And then once you clean your data, you want to encode the features. So you want to encode the categorical features. Let's say the seller offer type, all those things are there. So you are just dropping those extra features, but let's say the other features that we discussed, you want to encode those. So you can do some kind of one-hot encoding of all those. So you do pd.get dummies, and you can do one-hot encoding of those. And so this is the cleaning part and the pre-processing part of the data that we have done till now. Now we move to the train test split of the entire model. So we want to train the model via train test split. Like we want to split the data set into two parts. One is my so because it's a classification data set, so we have um, uh, it's a regression data set. So we have x values and y values, so, prediction value and corresponding feature value. So x10 is your feature, x test is your test features, y10 is your chain prediction, y test is your test prediction. So you're just doing this 10 test split, where your test size is actually equal to set to 30%. So 30% of the data is your test samples, and remaining 70% is your train samples. And you now use your linear regression model. You use LR equal to linear regression. You give a dot fit to train your model on top of it, and you do a prediction on top of this, like you predict the uh, corresponding uh, based on your after you train your model, you want to predict the corresponding output for the test variables. So and you can calculate your evaluation scores like RMSE, root mean squared error, and R2 scores also based on this. So for this linear regression, I would ask everyone to just maybe use your library to set this thing up and code it up. And once most of you are able to do this, we will progress with the random forest code. So we will take out some time to try this thing out, because it's already shared with you in the as a data set. So the code is already shared with you. You can just use it as it is. So yeah, so if you have any specific doubts in the meantime, you can just uh, share in the chat. So we'll start with the random forest after, if you are able to understand and code up the linear regression set. Okay, I hope you are able to set things up and try these things at your end. Um, so we'll move forward with the other part on random forest regressor. I think the previous part was on linear regressor. So in random forest regressor, we are using random forest, this function called random forest regressor, which basically is random forest, implements a random forest algorithm for this. Um and Here you are also doing the same thing. You pass your so you instantiate your random forest by following parameters like this, and then you want to train your model. So you do rl.fit to pass your x and y chain, which is your training data set, which is the features and the predictions, and then you do rf.predict on your test set to get the predicted outputs on those test sets. Finally, you do a root mean squared error between the test predictions and the actual predictions, and you get RMSE RF out of it, and do an R2 RF score, which is R2 score between the test and prediction scores. So these are like some of the settings here. And what you do is here we are showing like model wise comparison. So like for let's say for uh, different aspects of random forest versus your so this is just an illustrative figure here, but you can also plot these things at your end. Like if you want to compare which model is giving you better score, like for example, linear regression gives you better score than random forest or not. So you can make a histogram plot out of it and just check all these things. So now we'll look at the classification problem, which looks at getting a predicting a output class rather than a real value. So an example is that a public policy team wants to flag which individuals are likely earning above a 50K income threshold. So there is like a personal income classification uh, problem, which we call as classification. So the problem statement looks like this: that a government servant collects demographic and employment data from individuals, and analyst wants to predict whether a person's income is above or below $50,000 a year. And they want to only use the attributes like age, education, occupation, and number of hours worked to better target outreach programs. So on the right hand side, we are showing key predictors like age, job type, education level, occupation, marital status, capital gain and or loss, hours worked per week, and native country. All these are like features that governs whether a person has a specific income or not. And the target variable is my salary statistics, which is a binary variable that says by it's zero if it's less than equal to 50K dollars, or it's equal to one if it's greater than 50K dollars. So if based on my these features, I would have my target variables values as zero or one, depending if it crosses the threshold of 50K dollars or not. So why do we need a classification problem here? Because the target has exactly two discrete outcomes. Either it's less than equal to 50K or greater than equal to 50K. So there's a binary number. So that's why it's a classification problem. And we predict a class level here rather than a number. So the salary statistics is basically a categorical output type. With the income class is the description of the target variable. The other types are a mixture of numeric and categorical, like age is numeric, job type, education type, occupation, all are categorical types. Capital gain or capital loss is numeric, and hours per week is also numeric. So you can think of around, let's say, 32,000 records like this of people, and you want to predict. You want to train your model on both that data set, and you want to predict also. So we do the same thing. We again load all the libraries here first, and then we clean the data. So we load the library pd.readcsv, income.csv, and if there are any nan values, we are just so we are just doing it with this question mark here. and we are dropping those nine values along those axes once we have them. And what we are now doing is that we are converting the salary statistic column to a binary target variable. So we are mapping whether it's less than or equal to 50,000 or not. We are doing it to zero, otherwise it's a one. So this so now we do a one-hot encoding of the features. So we do pd.get dummies to get a one-hot encoding of the income dataset, income features. Then we drop the salary stat to get the feature in the train set or the x is basically my feature space, and then y is basically my salary stat column, which is the binary target variable. I even do a trend test split on top of it, which is test size is 30% of the entire data and 70% is the trend split. So I do x train, x test, y test, and do a trend test split out of it. And then I train my model on my x train, y train, and test it on x test, y test. So I do a logistic regression here also with maximum iteration set to 1000. I fit with x train, y train, and then I predict on top of x test my output, logistic regression output. And I then, since it's a classification setting, so I have a confusion matrix here. So I output a confusion matrix using the function confusion matrix, which is from scikit-learn library. It gives me between predicted outputs and the actual outputs, and also gives me the accuracy. So I can just run these things as it is here and get this values. So likewise, I would like you to try this thing at your end also once more for the classification aspects. So we are using a logistic regression here, although it's not a regression problem, it's a binary classification problem. But you can think the regression on zero and ones only. So you can apply the same thing here. So I'd like you to try out this code at your end and set it up and see if you're able to get the numbers correctly and all the throughout all the settings you're able to analyze the each of the code functions and all. So we'll take some time out to test these things out. If you have any questions, again, please feel free to post it in this chat. So I hope you are able to run these things at your end. I think it is a similar setting as to the previous setting that we are looking at. So we'll now look at the other kind of function of the model for getting a classification problem, which is called k-nearest neighbors. So k-nearest neighbors actually looks at um, a classification problem where you are trying to use some kind of clustering kind of aspects to uh, do the classification. So again, you can use the same function call here and get the confusion matrix and accuracy out of it. And you can also see like how many misclassified examples are there in this. For example, misclassified is y-test is not equal to the k-mean prediction. So these are misclassified examples. So you can use those also. So again, you can add, so the confusion matrix looks like this, like you have predictions on the columns and the actuals are your rows. And you are trying to you're trying to see whether how many of the samples have predictions less than equal to 50K and actual was also less than equal to 50K. So these are your true positives here. These are your true negatives. And then this is where your prediction is greater than equal to 50K, but your on your actual setting is less than equal to 50K. So these are your false positives and false negatives. So these are your corresponding different notions of confusion matrix here. Um, and so now we'll just summarize both of them. So the task type for the card data set was a regression, income was a classification. Target was a continuous, here it's a binary. And models used in both cases was you can use linear regression. And for classification, you have to use a logistic regression because you are using uh, corresponding class is 0 or 1. So that's why logistic regression. And then the random forest was used for uh, linear regression. Here also they use k-nearest neighbors. The evaluation metrics in case of regression is RMSE or R square method metrics. Here is more like accuracy confusion metrics and all. So if you want to do encoding, you can do get dummies on the categoricals to get encodings, and all these things are possible. So the key takeaways here is that a continuous target needs regression and discrete target needs classification. So this choice drives whatever the downstream accuracy metrics and all those models that you have to use. Uh, you also have to make sure your data is cleaned. So any outlier ranges, duplicate removal, missing value handling matters more to the results that the model in the final results. You can use ensemble trees like tree and ensembles like random forest analysis versus linear or distance models like linear regression or k nearest neighbors things. And you have to finally evaluate with the right metric like RMSE R squared is used for regression, accuracy, confusion matrix is used for classification. So you should not mix the two things together. So these are mostly the overall aspects of the course. I think for the logistic regression versus classification aspects. So if you have any questions, you can paste it in the chat in the meantime. So this is our last week of this course. We have covered the basics of Python initially about the different data types, then looked at NumPy and Pandas data frame, and finally the different plotting aspects, visualization aspects, and finally specific examples like classification versus regression into this session. So if you have any specific questions, you can paste in the chat. I would like to take another session. I think possibly I'm in talks with the NPTEL team to arrange for it, and I think they will probably let you know about the timings also. But overall, this is the end of the uh, 4 week session. So this is the last week of the course. So if you have any questions, feel free to share in the chat. I will try to answer them. So will we get the recording of the session? So yeah, so the recordings are available on YouTube. You can check them. So this recording for today's session would also be up by tonight. So you can check that also. Uh, so how to iconize file in VS Code window? So I'm not sure what you mean by iconize file. Um, I'm yeah, so I'm not exactly sure uh, the specific setting. The difference between marginal and conditional possibility. Uh, this also I'm not sure. Do you mean conditional possibility is what exactly? So do you mean probability or possibility? So I think this is a different setting. In Python, you don't have this kind of settings, right? So how to bring file in VS Code window? Once it appears in VS Code window, then you can type. So uh, you can open the file in VS Code, the CSV file, and then once you open the file in VS Code, you can go to the directory and you can. There's an option in VS Code to open a folder view. So you can open a folder view. So on the folder view, you'll see the CSV file on the left panel, and you can write a .py file also in the same folder path, which should be visible in the left panel once again. And then you can write your code in that .py file to read the thing and all. So the assignments, MCQs or essays, I'm not sure. You have to check with the NPTEL team for this. So they can probably answer this question. So marginal versus conditional probability, I think it's not part of the course syllabus here, but main difference is basically conditional probability. You have a condition on a specific event, let's say probability of A given B, let's say there's a conditional probability. Marginal probability is like it's like when you have different variables or events together. So you have a joint probability distribution out of it. So if you want to only check probability of A, let's say, which is a particular event, yeah, that's called marginal probability. And if you want to have a conditional probability, that means probability of an event given some other event has taken place. That's your definition. I hope that answers your question. Will there be a session to attempt how to? I think the how to attempt questions. I think this probably would be a common session held by the PMRF individual team to discuss on that, like how they want to do that. Is course coding sufficient job in corporate? Yeah, I think so. This course is just about the basics of Python in data science. Of course, it doesn't use you. You have to code up. You have to practice coding at your end, of course, to develop your skills. I think that's important. Yeah. So, any other questions I can take up now? So, if there are any questions, we can discuss. How does it? Since we still have some more time, I think if you want to test out the code at your end for this settings, we can also do that. I think if you have some, if you want to have any doubts on this specific settings, you can ask. We can pause till the end of the time to so that you can try out this code at your end. So yeah, you can keep on posting if you have any questions. I will try to address them in the meantime. some questions are there. I think we can take up a few questions at the end. So how sklearn differ from PyTorch or TensorFlow? They both case study can be executed in PyTorch or TensorFlow. Yeah, I think I think there are similar kind of libraries in TensorFlow also. So I think in standard Python you use sklearn and all, but with PyTorch also you can use. There are multiple compatible versions of scikit-learn that you can use, or you can define your own custom functions in PyTorch and TensorFlow also. So it's not hard to do those things because the data, how you read the data and all those things are different for TensorFlow and PyTorch. So you have to accordingly address for each of them. So any best book to practice Python for data science? I think I can't recommend a book at this point because since there are so many resources online, so you can check whatever you feel for a particular topic you want to learn on. There are multiple resources online to look for. Sources for getting more data sets is Excel. So yeah, so there are multiple sources like Kaggle datasets is one of them. Kaggle datasets. There is also UCI datasets, which is has a lot of such CSV Excel type datasets that you can try out. So even for scikit-learn library actually also has its own datasets that you can try. So you can check the library documentation on the website. Just check those things. Okay, I think that's all for today. I think once again thanks to everyone who has been joining this weekly sessions for the last few weeks. I hope you are able to gain some insights how to use Python for your projects and other areas. And I hope this can also help you in learning more advanced stuff like in machine learning and advanced concepts in neural networks and all. So thanks a lot for participating in the post session doubts and all. And I wish you all the luck for the upcoming certification exam and the final certification. And also beyond this, also in your respective fields and jobs, wherever you are trying to apply Python. I hope this sessions actually, series actually helped you in that. So thank you once again for joining throughout this course, and I will probably connect with you once again. I think if an additional session is possible. But you can find the recorded lectures on YouTube. You can search for Python for Data Science NPTEL, and you will get all the lectures based on that. So yeah, so thanks a lot. And if you have any questions, you can post to the NPTEL coordinator for the regarding the certification exam, uh, question types, and all these things. So with that, we'll be ending today, and thank you everyone for joining.